Hello and welcome back to my next video for Apache Nifi. So in this video we are going to cover setting up a quick and dirty Apache Nifi cluster, and this is going to be a 3-server cluster using Docker to do it in. So we're going to set up a Docker compose file. Before we get started, just a reminder, take a second there if you want to hit that subscribe button down below and the notify button if you want to be notified of new videos. All right, let's go ahead and get started. So first thing I need to do is check out, I've already created a Docker compose file that I want to use. Or I've made modifications to an existing one and I want to use it. Now, let's go ahead and buy that one real quick. All right, here's the file we're going to use. So version 3, we've got a couple services we're going to start. First one being the zookeeper service. And then after that, we are starting a Nifi 01, 02, and 03 service. Each one of them identical except for their ports. So mapping from the host internally to 8080, each one of the host ports that I'm mapping is different. You can see all of them, I've added a networks variable in here using the nifinet. All three of them have that added to their containers. And down here in the environments for the Nifi portion, you can see there's a couple settings we need for the environments. The 8080 port is being set. Nifi cluster is node, so it's telling this service it's part of a cluster, and that's true. The protocol to communicate on for the port, KD82. The zookeeper to communicate to, which is a zookeeper container up here. That's why it says zookeeper to match the host name up here of 2180, and then a max wait of 1 minute for the election in order to determine who is going to be the leader. And then down below, just a quick network, creating the nifinet using the bridge driver in order to get that done. So let's go ahead and quit out here. Go ahead and start up the cluster. Nope, wrong one. Oh. We're going to just do the up. And then we are not going to do the -d I normally would do because I want to put this in the foreground. I want to be able to see the log files as we boot up for the first time. Go ahead and get that kicked off there. You can see the images are already available because I've already ran it before, so they're stored on the system. You can see the log file for the zookeeper, Nifi 2, 1, and 3. Zookeeper's already started and running. And now each one of those servers we can see is expanding the NARs. So they're going to get that business done. Same thing they normally do when you start them up and you start a server up in standalone mode. So that's what they're working on right now. And then they'll get to the point where they're going to start their election, communicate to each other, and figure out who's going to be the leader in this cluster to start things off with. So I'll go ahead and come back as soon as they're done. All right, and welcome back. So the cluster is done with the election, as we can see here. So we're good to go. I have access to the web UI. So let's go ahead and switch on over to that. Okay, welcome to our Nifi 3-server cluster here. So we got 3 different nodes. And as we can see up here in the top left corner, so things are different about the UI. This top left corner right here shows us we have connected nodes and total number of nodes in the cluster. So there's 3 of 3 right now, so all of them are connected and working. And over here on the far right, we just have an error because they're little heartbeats thing, so that's no big deal, it's just an info. This will clear up and everything will be fine because they are communicating just fine. Now let's go ahead and take a look at a couple other things that change in here. So if we go over here to the menu, we can see we have the cluster option in here that we can click on. We'll select that. And here we get a list of everything in our Nifi cluster. So all of our nodes that are currently available. We have the address to all of them. In this case, instead of an IP address, we have the container address and the port number. And then we have active thread counts, the queue size for each one of them currently, where they're at, the status of each one. So we can see the first one up here on the list is connected, last one's connected, the middle one is connected, it's also the primary and the coordinator. So it's got a couple of extra responsibilities there. When they were started and when the last heartbeat came in. And they're constantly sending heartbeats to each other. Okay, so we can also see that we do have an option to disconnect a node from the cluster from here. Under system, we do see that they all get listed here as well. Now, all these are being ran on the same server, So the server itself is a 32 core machine with 32 gigs of RAM. So they're each going to report 32 cores and the same load and not the same thread because it depends on what they're doing. Okay, so JVM though mostly look the same in a lot of areas here, but not everything because they all do run their own JVM in their own containers. File storage though will be identical because they're sharing the same host machine. Content storage, Providence storage, and version. All right, we can also see that because this is using the Docker file, which is set to the latest version of Nifi, the current latest image that was available was 1.12. So that's what it has right now. All right, let's go ahead and get out of here. And let's go ahead and bring in and create a quick flow to look at some of the differences and some of the things we want to consider and look at a little bit of throughput as well for when we're running a Nifi node. So what I'm going to do is I already have a flow created that we can use, and that is going to be imported. Let's go ahead and use that. Select the template, have it right here, call it my cluster example. I'm going to upload it. That was successful. That's good. We're going to drag it. We're going to select it from the list, add it, and here we go. So I already have a pre-made example here that we're going to utilize. We'll take a quick look at it and see what it's doing. And we have to edit and fix a couple parts of it too. So I'm using a generate flow file. And in this generate flow file, we are just creating a quick flow file. It's in a JSON format. So this is a JSON from our aviation data that we've been playing with. And then I gave it a BB type of application JSON as well. So that'll take care of that. Scheduling is set up as well for one and set to all nodes. Okay, we'll leave that one alone. We're going to make a quick change in here. Go back to a 10. Put this back on its default. Do not load balance. So this is what it normally looks like because we'll play around with some settings on that. So this is going to generate a JSON flow file. We're going to do a convert record on it. And what we're going to do is convert the record from JSON to Avro. So in order to do that though, we need to set up the JSON tree reader and writer. You can see during the import of the template, pretty cool, right? It brought in the reader and writer. They just need to be turned on and activated. Okay, that takes care of that part. So now we'd have no more issues with that one. The convert record, we're just going to take a look at it, make sure everything looks legit, and that should be on 1. This one goes down, there we go. Merge, just set things back to the defaults from when I was playing with things. Okay, that looks good. Looks good. Same here. And same here. Okay, so this is going to be our flow that we're going to be working with. Now, there are a couple of things we want to understand differently about it. So in a cluster environment, we have 3 nodes. So how does that differ from a regular standalone environment? Well, let's go ahead and take a look. We're going to go ahead and do a generate flow file on here. Right click on it and we'll start it. And we can see it's quickly making a lot of flow files. And we can see up here, it shows 3 active threads, and it shows us in the total environment 3 active threads as well. That's a little different, right? Because if we go back and look at this, under scheduling, we only have 1 concurrent task set up. So what's going on here? And another thing that's really weird is the queue has 30,000 as its limit, which is odd because the back pressure is set to 1,000 objects. So how does that work exactly? Well, when you're in a cluster environment, everything is basically multiplied by the amount of nodes that you are working with. So in this case, this generate flow file is running on every single node. So that means 3 of the same thing are getting produced at the same time. So let's go ahead and stop that and take a look at that. Now, under execution, in a standalone environment, it doesn't matter because you don't have any other nodes. But in a cluster environment, you have 2 options total. You have the all nodes, and then you have the primary node. So the primary one will only be ran on the primary node, which, if you remember, when we go back over here and we look at our cluster, that means this node right here is the primary, And if we select that option, this one will take all that work and it will be the only one to process it. And it also means because we have three different queues that are being utilized as well. So our queue gets bigger too for our settings in there. So let's go ahead and clear all of our queues and make a little bit of change here. Configure this one back up. We're going to run on the primary node only for right now. And everything else should be good. All right, so stop that. Now, one big difference to see here in the UI is on the processor itself, it now indicates a P in the top corner where the other ones don't have one, indicating visually that this is going to run on the primary node. So, and the tooltip pops up as well when you hover over the P, indicating that as well. So that's kind of nice to know. So let's go ahead and start this one back up again. There we go. And as you see, now our queue size is only 10,000 because we only have one. The primary node is the only one running it. So it's the only one who has a queue that's getting filled up for the back pressure right now. So let's go ahead and take convert records and start that one. So convert records is set up to run on all nodes. Let's go ahead and take a look at that. But as we saw there, that quickly ran, so not too bad. It couldn't keep up here. It wasn't able to drain that at all for that back pressure. Let's go ahead and do the merge, the compress, the update, and then on the route, what I'm doing here, something slightly different. I'm not setting it anywhere actually. I just have it using this, and then it's taking the outputs from is and unmatched and just terminating those. So we're not keeping that information around. So we can run this indefinitely without having to worry about anything right now. Now let's take a look. So what other things do we see that's different? So we have primary node being ran up here for this processor only, which means the queue size 10,000. What's odd here though is we can see over here, this one's only consuming one active thread. Now I thought I just told you that we are running this on all the nodes. Yep, execution is all nodes. So why are we only seeing one node actually doing the work? And we can verify that too. So just like we can go up here and we can say view status history, we can see up here, all of our nodes that are part of our cluster will be listed. We can uncheck them to see what it looks like. So in this case, this solid blue one is the Nifi cluster itself. And then all the other colors, so we'll get rid of that one, are all the elements, or all the individual nodes in the cluster. Now, as we can see here, we are only, before we were running on all of them, so we had a quick little boost there for all of them, but now we only have one doing all that work. So it's generating all these flow files, which is the reason why only that green line is continuing to rise up until it gets to its total threshold where back pressure kicks in. So what's weird though is that we're still, if we go look at this one, only one node is actually doing any work here. This doesn't make any sense, does it? So we're actually being limited on our total processing power here because two other nodes are just lying around waiting for some work. And in this flow, they're not getting that work handed out to them. So how do we take care of this? Well, there's a way to make sure that they get some work. Let's go ahead and stop this up here. And we'll stop this one down here. Okay, we got a couple left in the queue here. Let's go ahead and edit this queue. And inside the queue now, we have a couple of additional options that we haven't used before in the past because they weren't needed. One of them being the load balance strategy. So by default, we're set to do not load balance. But we have other options we can do. We can partition by attributes. We can round robin it, or we can have a single node do all the work. All right, so single load balance compression as well. You can set up compression if you want to, if you're needing to, but in this case, we're not going to mess with that. So single node is not what we want because we want to invite all of our nodes into the workload. So let's go ahead and use round robin. You also see we have a couple other things as well. So available priorities are here, so we can, which is what's always been there too. So we can say first in, first out, newest flow files first, prioritize, or yeah, newest flow file first prioritizer, the oldest one, and priority attribute. So based off an attribute setting. But really all we need here is the round robin. Let's go ahead and apply that one real quick. And then let's go ahead and start things back up. So we got 345 sitting in the queue. We'll start this one back up. It's going to get filled up again. There you go. So now we're back up to 30,000 because the queues for all of them are going to get populated. And we see there's a change here in the queue visually. And when we hover over it, we have a little thing here showing load balance is configured with round robin strategy and no compression, actively balancing. So now we have 3 individual queues that are available to us for each node. And that's why it goes up to 30,000 now. So we can go ahead and get that started. And now we know that each new flow file being generated up here is being load balanced with a round robin strategy to each of the individual nodes. So now we see up here, well, it did bump up to 3. So we have 3 active threads going here, 1 for each of the individual nodes. And it does drop down a little bit, so it's trying to stay busy here. And merge content is not having a hard time, and the reason that is it's having an easy time keeping up is because the merge is set up to take basically for every 1 flow file, or for every 1,000 flow files coming in, we're getting 1 flow file coming out of this processor, and it's binning up to 5 different maximum bins at one time, so it can handle quite a bit at once and get a lot done. Now, one thing I do notice though is that we are unable to really get that queue emptied all the way. It gets close, but it just doesn't get all the way down there. Now it is down to 10,000 instead of up to the 30,000 range, but it does bounce around a lot. And if we go in here, we can take a look now in the history. So we can see we still only have 1 in this processor. Only the 1 node, the primary node, is still generating all the files. But now when we take a look at the convert, we can see easily here that the other 2, because 2 of them are just right on top of each other, are starting to make their way up as the load gets figured out. And they'll probably, all 3 of these lines will eventually merge at some point. You can see it happening down here, right? It's starting to get there. We have a point where they're going to intersect to each other and collapse down. So now they're all working together. So it's pretty cool. We can see that they're getting a lot done. We can also see that they're processing, the convert now is processing, it's taking in 1.5 million and putting the MAC out pretty quickly as well, which is equivalent to, so far in the last 5 minutes, it's already processed over 1.9 million in total reads and writes, or for the writes out. So, what is it, 1.9 million? I meant 2 gigs, or 1.9 gigs. So we can see this is working pretty well, but we're still not keeping up performance-wise, right? We're not emptying out this one, and we only have, I mean, we have 1 here doing all this work, but these 3 aren't keeping up. And most of that will have to do with the convert process, like what's the cost to do each one of these conversions. But we can probably improve this a little bit, so let's go ahead and stop it and see if we can bump up our performance a little bit. So we're going to change our run duration, and this is kind of like, this is the best way to explain it that I've been told is it's like micro batching. So it'll run a little bit longer and get a little bit more done. You can see it says lower latency down here, and then as you move towards here, you can get higher throughput. Although I feel like you go a little bit too far, you start to get diminishing returns depending on the processor and what you're doing with it. So I'm going to bump it up to 25 milliseconds. It's going to wait. We'll still leave it at 1 concurrent task. So that means 3 are still running, 1 for each server, but they're going to take a little bit longer to run each one and see what the boost is. So we were around 1.69, and see if we can get a little bit better performance out of that. Immediately start jumping up 7.2 or 7.32, 7.6. And we noticed right away that we cleared the back pressure inside that queue. And we're basically hovering around 1,000, looks like. Yeah, in the 1,000 range there. So this queue is actually being dealt with pretty easily now. And now we're up to about 2 million, and so it's not the full 5 minutes yet, but you can see we're much busier now. Let's go ahead and let's increase how many records we're creating. So instead of doing it just on the primary node, we'll go ahead and switch it back to all nodes. This will really blow things up for us. There we go. The queue gets filled all the way up to 30,000 pretty quickly. So now we're back to the convert record not being able to process quick enough. It is using up 3 threads, one for each of the servers or the nodes, and it has a little. The duration time was tweaked, which got us better performance or throughput. But now we're back at a point where we can't keep up to this back pressure here. So we notice down below we're bouncing around back and forth, but the merge is doing pretty well by itself. And every once in a while, it's having to kick in an extra thread from one of the other nodes. So but we're not using a merge strategy, or we're set up for execution on all nodes, and you can see concurrent tasks. So if I remember correctly, I believe what happens here when you don't set a load balance strategy is that once one node becomes full, so it has back pressure and it's too busy, then it starts sitting that work on to the next node and then the next node as they become too busy trying to keep up, right? So I believe that's how it works. So that's why we see like this will bounce around between 1 or 2 active threads, where you don't see it going up to 3 because 2 are basically able to work with the load. And that's why we see it bouncing around in the queue so much. But it's really, one can mostly keep up. Sometimes it needs to help out the second one, depending on that. I think it really comes down to the binning. Like if you adjust your bins a little bit, you probably see one might be able to do a better job. You just have to play around with it and tweak it till you got there. But we can see we're definitely not keeping up here. So let's go ahead and just make a quick bump here, and we'll go ahead and bump up the convert record here. Let's go ahead and stop that. And we're going to say, okay, well, run duration did help. I don't think it's going to give us much more on this processor if we keep bumping up a little bit on the duration. So let's go ahead and move up by 1 more task for each of them. So each node will run 2 concurrent tasks at once, which gives us a total output of 6 tasks at one time from this processor. We can see we easily, at the start there, get up to 6, and it looks like it's going to maintain 6. It's not able to clear out the queue all the way right away, but it is, looks like it's getting a little bit more fluctuation in the back pressure here. All right, so let's go ahead and look at a couple other things real fast. So if we go back to the menu, go back to cluster, and we can see here now, we can see the queue size of each of them, how they're performing right now, the total active thread count for each node in the cluster. And we can go ahead and look at the system, JVM, and all the other stats that are available as well. So we do have some options in there. You can also take a look at our history again to see how our nodes are performing and how the cluster as a whole is performing with handling the data as well for each of the processors. So we can see 2 started merging together, so now 2 are definitely busy all the time. And actually all 3 of them are busy now, so they're keeping up with each other here because they're all 3 using all 6 processors or threads that they had available. All right, so really the biggest takeaway I think is you want to pay attention to how the processor will react when you're running it inside of a cluster environment. And there can be some very serious negatives depending on how you're using it. One good example that I'll just point out here, if I take this and I do my execute, that is not the one I want to do, but actually I think that would be a good example as well. But let's go to an execute SQL, right? So if I have this in a cluster and I run this and I leave it on all nodes, that means every time this one execute, each one of the nodes will run the exact same query script that I have in there. So I'm querying the same data 3 times from the same database or source, and I'm duplicating my data multiple times here. So it's I found out when using it for the first time in a cluster environment, you want to make sure that you do things like, hey, set your queries to only run on a primary processor. This is also true when you're doing stuff like, say, depending on the other processor, but like maybe put SQL, right? Meaning that when one flow file comes in here, depending on the strategy you have set up and stuff, you could end up writing it 3 times, depending on how you do things. But when you execute for sure, you'll see this get executed 3 times by each one of those processor. May not necessarily be true for this one, because if you have it set up this from the convert JSON to SQL before this one, and you're feeding it into here, and you have the queue set up for a round robin, then I think you should be able to pull that off safely, because it's sending one flow file to each one of those, so you're not going to see any problems there. Really, you want to be careful on just like when you're running silk queries. Those are the biggest ones I've seen problems with. So there you go. Just a quick idea on how you can, when you do run in a cluster, you can scale up pretty easily. You can run a lot of throughput in here. I mean, we can already see that we're not even keeping up on this back pressure here, and we're starting to get back pressure down here on the merge. But I mean, we're moving 6 million flow files through here, 7.8 gigabytes in the 5-minute time window that this one is providing us data for. So that's quite a bit for what we're doing just on 3 nodes real quick. And when I glance over at my terminal for my server, 32 cores, we're hovering around 50-ish%. As a matter of fact, we can even see when we go to summary, and I think this will give us the right numbers. System, yeah, so around 50% in the last, this is 1 minute windows. Yep, last 1 minute. So 56% utilization across those 32 cores, and 93 cores available. And the reason we get that is, say these we were on. So another thing you want to pay attention to too is your, real quick before we stop, controller settings. So inside of the general, where you set your maximum timer driven thread count, this is no longer 10 for my entire environment or 10 across my entire cluster. This is 10 per worker. So if you're doing a 1 core 4 threads type of ratio, then you would want to make sure you adjust this number to, it's automatically going to apply to all of them. So you still want to keep the number based off of, if I have 2 cores, if I have a 2-core machine and I want to do a 1:4 ratio. So my 2-core machine, I would say I want to run 8 threads on it. Then I still only put 8 in here because that 8's going to be applied to each one of those. So my total number, the total number sum is the multiple of this against whatever your cluster size is that you have. And then that's what you have overall across the entire cluster available. And then the other thing is, just keep in mind for clusters, each flow file, like in this case, we're doing round robin. That means each individual server has that one flow file. That flow file is not reproduced across all of the servers. It gets routed to that individual server, they'll do its work, and then sent back over to wherever they end up going at the end. So they're literally splitting out the work to each other instead of like, hey, let's duplicate it and all process the same stuff. They don't. That's not how clusters work inside Nifi. All right, that's all I have for you today. Don't forget to hit the like and subscribe if you enjoyed the video, and leave a comment if you have anything you'd like to add or contribute as well. Talk to you next time. Bye.